So let's look at a few things.
Oh, cow. Sorry.
So one thing you'll have to do is you'll have to go to your homework project, and then you'll have to run the, it's called NuGet Manager, and you'll install package Mongo C# Driver. You have to do that. You didn't have to in the other project because I had already done it. And then you'll have your form just like you do now, and it has these three fields already there in text boxes. I added a button up there to click, which will jump to a new page, and it'll read the Mongo data and display it. That's how I get to it. I click up there, nothing fancy. Okay. Now, when you click on this today, if you had your homework working, it passes back the credit card and the phone number. I'm requiring you to pass back the credit card, the phone number, and the name, as well as I think I require the price, but not the part number. So you'll take those four things, put them in an object that you create, an order object, and then push it up to Mongo.
There's a boot.
So this new object that you're going to push up to Mongo is going to have this thing called a GUID. It's going to have the credit card number, the phone number, the price, the name, and the date. It should have had the CVID, but I screwed up and didn't include it, so we're not going to do it. Right, so you'll create an object like that, and then you'll have a constructor for it, so that whenever you create one, it'll take the current date time and just shove it in there. That's a really easy C# thing to do.
So if we want to put the CD in, probably put the title versus the ID.
I wouldn't mind, but either way. And right now, when you click the buy method, it goes to the web form event and passes those things. You need to pick up that extra value of the name, and then you'll have to modify your buy method to accept that extra parameter. And then you're going to create three methods: a log order method, and it doesn't return anything, but it'll take that object that you just created, an order detail, and what I'm suggesting you do is just insert this, and it does nothing. And then have another one called get all orders that returns a list of orders, create an empty list of orders, and then a clear history which does nothing. What I'm doing is it's a way I like to program, which is like you pretend that methods exist. So you write what are generally called stubs. And the stub is just the method definition and a return if required. Then you can code up the main program to use these three methods. So in your access by method, right after you commit the transaction, you'll call this new method that was on the previous page that says log the order. And you'll have to instantiate the Mongo DAO class that we used. And if nothing blows up, you're good. It's not going to do anything, but it'll call your method and return and do nothing. But that's good. And then you're going to have to create a new ASPX page and give it some kind of a heading, and then a status message, and then you have a repeater. You could use a data list, but either one will work here. And then add a button that says clear order history, and then double click that button, and it'll create an empty method. In that, you'll make a call to that other method you just wrote, clear history, which does nothing. So you're just we're modifying the SQL code to call three methods that don't exist. And then this order history, the C# page that goes behind it, in the page load method, you'll create a list, and then you'll call that method, order details, MyDal, get all orders. Now right now, that's just a stub. It won't get you anything. But it's going to return an empty list so the code won't fail. And then you use this repeater code to display the data. And I have it set up so there have been, count how many entries there are, and it writes out how many entries there are. So, you know, there's 10 entries, there's 20, there's a million. And now your old code works, but it's not really talking to Mongo. So then you have to go to these three methods and make them work. The log order one will take that order object and push it up, just like we pushed up the note in class on Tuesday. The list one will do a call to the Mongo cloud to get all the orders back. And then a clear history will be a call up to Mongo to clear the database up on the Mongo side. And that's it. Don't cry. She put her finger in her eye. I thought she was starting to cry. You can do it. You can do it. So, let me open up my version of last week's homework, which is I'm not allowed for you to work on homework in the class, apparently, because the way these classes are certified or accredited, like, this is not a lab. So we're allowed to work through exercises, but you're not allowed to work on your homework. So if anybody asks you, you're not working on your homework. Otherwise, they'll put me in teacher jail, wherever that is.
I'll try to remember to edit that out for you.
Yeah, as a bribe, I know you're going to correct me. I'll go tell Sylvia, you let him do homework in class.
I would never do such a thing.
So here's an example of, this is my working homework that you would have had done on Tuesday, okay? The first part is getting the customer data to create the data list, not a data list. Yeah, data list. Okay, that's just doing a SQL read. I think you know how to do that. And then here's the buy method. This is the one that you're going to modify now. So the buy method currently is getting passed up the credit card number and the phone, and then it's getting this other chunk of data that was passed, which was the concatenation of two words. Okay. So where do I split that? Here I say words equal that parameter split, and it uses the space and it splits it and makes an array of two words. So now array 0 is going to be the PCID, and array 1 is the CD price. So what you're going to do is, because I'm making you pass up the person's name is, you're going to concatenate a third string onto that parameter. And then when you do your split, you'll have 3 elements in that array. And then you'll have another line here where you will say the username is equal to words dash 2. Right? So now you have those 3 properties. Now in this one, we create a thread. I create this data object that I pass into the thread. That's nice. And then I load it up with the data, and I call to check the credit card. That's part of the old homework. And then I wait. until the thread's done. And when it's done, I do a query to write the order that update the inventory. So I do an update and I drop the quantity by 1 if the quantity was not equal to 0. And then I create the transaction, open the connection, start the transaction. I do the command, and then I check how many records were changed, because when you update, it'll tell you how many records were changed. If this comes back not equal to 1, it failed. And I sort of get optimistic and I say, it worked, thank you for your purchase, but then I actually check it. I check, did the record change not equal to 1? Which means if it didn't change 1 record, it failed, or if my credit card was false. In either case, I roll back the transmission, and then I check to see which error message to send back. If the credit card was okay, I say we must have been out of stock, otherwise I turn the credit card. Okay, at this point, otherwise, everything was fine, and I commit the transaction, and I originally set the return message to be thank you. And then, looking specifically at the second row to the left, my left, close the connection here. If you don't close this connection, when you try to order the second one, it'll lock up on you. You should be able to order, click, 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 keep ordering. And if you haven't closed the connection, your program will hang up on you. Okay. At this point, you have now successfully, well, actually not at this point. It's, in my case, it's here when I have decided that everything went well. This is where I want to log the order. This is where I will instantiate this new object that has all the information I want to write up as a JSON, but you don't have to make it JSON. And then I will call this method here that says log it, and that will log it. And then you can open up your connection to MongoLab and see that you're successfully writing records. And I wouldn't go any further until you had that part working. Now, this object that we need here, what did I say about this object? This is the object you're going to have to write up to the database. And it'll have this property which you won't set. It'll set it for you. And then you'll plug in these values which are sitting around in your program. And then you'll call that method.
So you said even if we have to if we roll back, we don't want to send it up?
Right, you don't want to log it if you didn't. We're only keeping track of successful orders. Okay, now this is probably my working copy. And okay, so this is a little bit non-obvious. So non-obvious that I think I would probably post it. This is my object that I'm creating that I'm going to send up to the cloud. Okay, and I called mine an order detail. All right. So it has this date-time property called date. And then it has a constructor, and the constructor, every time you call it, sets that private property date to be now. And then here's those other properties. I have this ID generator, and then I have credit card, phone number, price, name, date. I have a strong feeling this is not required because we didn't use it before, but it worked. But it's probably the right way of doing it. You're in effect, you're providing this sort of two-way mapping. You're saying, when this object is read by my C# code, it's a public decimal. But you're also telling it when you push it into, you're labeling it when you're pushing it into this DAO Mongo library that does the reads and writes to the database, that it should treat it as a BSON element, which is another form of JSON. And these are the names that will be up on the database. So these names could actually be different, because this is the name that'll be up on the cloud, and this is the name in your C# code. And you're doing an object relational mapping between, well, it's not really relational, but you're doing a mapping between this name and that name for every one of those. Okay. And why do I have a get name return to over time? Oh, this is interesting, I guess. I know. I'm going to guess that the way they keep time and the way we keep time are different. And when we want to reference the date time, we're going to get that, and then this is probably in universal 24-hour time, and this will be local time.
Yeah, they store it in UTC, so the time zones will mess everything up. We had that happen at work, and we had to convert everything because, what's it called, daylight savings time happened, and then all of a sudden everything was off by an hour or a day, depending on how we had it set.
Right. So I'll post this, because this is a tad bizarre, but I think you understand what it is. So then, this is this program. I want to go back to the other program. So in this program, which would have been your homework, just when you commit the transaction, you've just done an order, you want to create one of those objects, and the constructor will set the time. And then whatever you call your object, you'll have to say the credit card value is equal to, the phone number is equal to, blah, blah, blah. Set all those properties. And then you'll have that call that I told you to make in your database, which will be, you'll say, like, public void log order, and you'll do that. Now, that's going to be in this thing called Mongo DAO. Now, what is Mongo DAO? It is a new class you created, and you copied and pasted in the Mongo DAO we had from the in-class project.